So today, we're diving into a really cool breakthrough in AI. And what makes it so special is that it's inspired not by, just throwing more data or faster chips at a problem, but by looking inward at how our own minds work. Specifically, our incredible ability to pay attention.
I mean, seriously, think about it for a second. Right now, your brain is zeroed in on my voice, but at the same time, it's effortlessly ignoring the sound of your air conditioner, the feeling of the chair you're sitting in, maybe a dozen other things. How on earth does it juggle that constant flood of information without just crashing? Well, let's get into it. The secret to how our brains pull this off lies in this amazing cognitive theory, a theory that is now starting to completely shake up how we build AI.
Okay, so it all comes down to something called attention schema theory. The big idea here is that our brain doesn't just pay attention, it actually builds a little model of its own attention. It's almost like it's aware of what it's focusing on. And this model, this schema, is what lets it understand, predict, and, most importantly, control where all that mental energy is pointed. The best way to picture this is to imagine a tiny manager living in your head. Now, this manager isn't doing the actual work. Instead, it's constantly looking at all the incoming tasks and deciding, okay, this is important. Put our resources here. That over there, not so much. Let's ignore it. It's the reason you can tune into a single conversation in a loud, crowded party.
So that brings us to the million-dollar question. If this little attention manager is so absolutely critical for us, what about AI?
Now, don't get me wrong, modern AI, especially those huge transformer models, already have something called an attention mechanism, and it is ridiculously powerful. It lets them see the big picture, weigh what's important, and even focus on multiple things at the same time. But there's a huge piece of the puzzle missing. They've got the raw horsepower for attention, for sure, but they don't have that internal manager. They're missing a model of their own attention. And because of that, they can be pretty inefficient, they can be inflexible, and they really struggle to adapt their focus in a smart, targeted way. Which, of course, led researchers to ask a pretty obvious but profound question. Could we actually build one? Could we give an AI its very own attention manager, borrowing the blueprint from our own brains? And as it turns out, the answer is a big, resounding yes. And it's a game-changing upgrade. So say hello to ASAC. ASAC stands for Attention Schema-based Attention Control. It's basically a new module you can plug right into an existing AI. And it does exactly what the name implies. It gives that AI the one thing it was desperately missing, that internal model, that schema, to manage its own focus.
So how does this thing actually work? Well, it boils down to 3 key jobs. First, abstraction. It creates that simple map of what it's currently focused on. Second, manipulation. It uses that map to tweak its focus, cranking up the signal on what's important and tuning out the noise. And third, prediction. It actually starts to anticipate where it should pay attention next to get the best results.
Now, the secret sauce here is a component with a very technical name, a VQVAE. But forget the jargon. Just think of it as a toolbox. As the AI learns, it starts filling this toolbox with all these different proven attention strategies. So when the ASAC manager faces a new problem, it just reaches in and grabs the perfect tool for the job. Okay, that's the theory. Sounds pretty cool, right? But does it actually work in the real world? Well, let's take a look at its report card. So on a straightforward image classification task, the difference was like night and day. Compared to a standard AI, the one with ASAC bolted on learned way faster, and it ended up with a higher final accuracy. It wasn't just a little bit better, it was smarter and more efficient. And this proves it wasn't just a one-time fluke. They tested it across a whole bunch of standard vision datasets, recognizing everything from cats and dogs to different types of clothing, and the ASAC model consistently and decisively beat the baseline. But this is where things get really interesting. Check out how ASAC handles multitasking. When they asked the AI to do 2 jobs at once on the same images, the standard model kind of struggled. But the ASAC model? Its performance just exploded. I mean, look at that triangles dataset. It jumped from about 78% accuracy to nearly 97%. That shows a kind of mental flexibility that starts to look a lot more human. And this adaptability makes it way more ready for the messy real world. The ASC-enhanced AI was much better at handling noisy or weird data it had never seen before. It was tougher against certain types of cyber attacks designed to fool AI. And get this, It was even better at learning from just a handful of examples. So it's tougher, it's smarter, and it's a faster learner. And here is the visual proof of that manager hard at work. When they gave it two totally different tasks, like telling cats from dogs versus reading house numbers, ASAC developed completely different strategies. You can literally see it here. It's pulling different tools from its toolbox for each job. It's specializing. But, and this is the really clever part, look what happens when the jobs are similar, like identifying different diseases from medical scans that all kind of look the same. ASAC is smart enough to realize this. It reuses the same attention patterns for both tasks. It doesn't reinvent the wheel. It's efficient. Sound familiar? That's exactly what our own brains do to save energy. So let's bring all this home. What's the big picture takeaway from all of this? What does it mean for the future? Well, I think the researchers who built this technology put it best. They said this isn't just about another small performance bump. It's a huge step forward in a whole new direction, building better AI by looking more deeply at the principles of our own minds. So here's why this really matters. What ASAC gives us is a blueprint for making AIs that learn faster and are just plain smarter about how they use their resources. This could lead to systems that are way more robust and can actually handle the chaos of the real world. But I think the biggest lesson here is a powerful reminder that the next giant leap in AI might not come from a bigger computer, but from a better understanding of ourselves. And that leaves us with a pretty wild thought to chew on. We've just given AI a sense of focus, a way to manage its own attention. If it can truly master that, what other uniquely human abilities, like intuition or maybe even consciousness, might it start to learn next?